Hello there. Today we're going to talk a little bit more about the periodic table. All right, we're going to talk a little bit more about reading and understanding the different elements on the periodic table. Today's focus is about why the elements are where they are, or at least the first time we're going to talk about that. There's a very specific answer to that, and there's actually lots of different answers to that. But the big picture, the short answer and the very most important answer is why are the elements where they are is because of some of their properties. By properties, I mean things like density. Do they conduct heat and electricity? Do they react with other elements? Do they create chemical reactions? Are they shiny? All right. Are they magnetic? All right. All of these are properties, things that we use to describe objects, and these things are organized by those properties. All right. For example, aluminum, or as it's actually properly pronounced, aluminium and silicon, they're right next to each other. They're right next to each other on purpose. Right? It's not alphabetical order here. They're next to each other on purpose because they're very similar to each other. All right? Sulfur and oxygen, or fluorine and chlorine, all of these elements are right near each other because they're very similar to each other. All right? With that saying, the same logic goes in the fact that calcium is very different than neon. And thus they are very far apart from each other on the periodic table. All right? Francium is very similar to barium because it's near it. Right? Francium has some similarities to, say, chromium, because they're not next to each other, but they share similar properties. Not a lot, admitting. All right? But francium is nothing like oxygen because they are very far apart from each other. Right? Oxygen being O. All right? And it is all based on the properties. And we can kind of put these properties, as throughout the semester, we'll talk more in specific about very specific properties such as electronegativity, talking about valence electrons, energy levels. There's a lot of different properties, ionic charges that we'll be talking about. But let's talk about it in a very broad sense. All right? And that's talking about which one of these are considered metals, which one of these are considered nonmetals, and then which one of these are considered metalloids, which is a little bit different. All right, before I switch you guys over to the board and we take notes, one thing I want you to take a note of when you're looking at my periodic table, because it's going to come back into when we talk about it. Notice here, and you may not be able to see it super well, but there is a thick black line right here. Almost kind of like stairs. I want you to remember this, that there's this thick black line on the one side of the periodic table that almost goes like stairs down the periodic table. And there's actually one more thick black line. And it's right under here, right underneath the hydrogen, the H, between the H and the Li. So there's a black line there, and then there's the black staircase. I like to call that the black staircase. Keep that in mind as we travel and warp all the way over to our whiteboard. Whoosh. Okay, so let's talk about how these are organized in biggest picture between metals, nonmetals, and metalloids. All right, so you guys have out your handy dandy notebooks. All right, and I would start with the silhouette. Again, like we did in a previous video, silhouette of the periodic table. The only difference is I add a little dashed line where I put that black line here for underneath the hydrogen, and then I put my black staircase. How you put it exactly, that's fine. We're just drawing an outline. All right, we'll update your periodic tables very specifically later. All right, so we're just drawing a little dot. I just drew a little staircase. I'll give you a moment to draw that. You can pause the video. I'll wait. All right, now that you have this set, let's talk about how these are set up. Most of these elements here actually have very similar properties. Most of the elements, there are 118 known elements that we know of. That's 118 different types of atoms that exist that we know of. Could be more, but it's the ones we know of, and some of them we had to even create to exist. All right, there's 118 of them. Most of them classify under the term of what we call metals. All right, and the biggest chunk of how I've kind of separated this, I separated this one, I separated these ones from the middle ones. Notice this biggest chunk right here, that's the most elements. Most of the elements fall in this middle part here. These are what we call metals. Like this one here, or these ones right here are called the alkali metals. These are the alkaline earth metals. These are the transition metals. These are actually called the other metals. There's more specific names on this there. But this biggest chunk here in the middle, where the most of the elements are called metals. Most elements are what we call metals. All right, and now we all conjure up an idea of when we think of metal. We think of something like shiny, typically kind of hard. All right, there are different types of metals within there. There's a whole range, but they do have some very similar characteristics. All right, so just some basic characteristics. They typically are very shiny. In science, we use the term luster. Luster is how well light reflects off of something. Some of them are a little bit more lustrous than other. Lead right here, it's kind of like a really dark gray. So it's not as shiny as, say, chromium, which is about right here. Chromium's like chrome. Chrome's that very shiny stuff. You see them on really nice tires, on cars, that really shiny metal. All right, that's chrome, and that's lead. Both are shiny, but different levels of it. So understand, it's not just shiny or not shiny. There's different levels or shades of gray kind of in there, if you will. All right. Metals are typically they are very conductive, or they are conductive. All right. Which means they allow heat and energy to travel through them. Copper, which is about right here, is very conductive. Something like sodium is not quite as conductive. There's different kinds, but they are conductive. They allow heat and electricity and energy to pass through them. All right, some are just more than others. All right, they are typically magnetic. Again, some are more magnetic than others, but they have varying amounts of magnetic. You could put a magnet next to them, and they would stick to them. Gallium is pretty magnetic. All right, but there are some that are not quite as magnetic, and they are typically pretty reactive. And by reactive means they react with other elements. We typically can test this by putting a little hydrochloric acid on them and see if they bubble up or fizz. Things like these ones here are extremely reactive. These ones are very reactive. And typically as we go from here, it's extremely reactive, less reactive, less reactive, less reactive. It's becoming less and less. So the most reactive ones like sodium, lithium, potassium, these are very reactive. They actually can, if you put sodium in water, it will react so violently, the metal will catch fire and explode. All right, if you ever heard to type in or YouTube sodium in water, it's pretty cool. All right. So those are just some common ones. There are more, but I was just kind of going big picture here. All right. So that goes to kind of the other side of this. All right. So if we don't have metals here, the next biggest chunk of them are going to be on the other side of those dotted lines or the thick black lines or the staircase or this one up here. These are the non-metals. These are the non-metals. All right, which also includes, pause there if you're, put your pencil down if you're writing right now, also includes this one right here. It's the ones to the right of the staircase, right? And this one. You say, well, wait, if they're all supposed to be next to each other based on their similarities, why is hydrogen a non-metal, not with its other similar friends? We will answer that question. It actually has a lot in common with these metals, but it's a non-metal. All right, and we'll get to that, I promise. All right, so non-metals, they're almost kind of the opposite of metals. They're literally not metals. All right, they are not shiny. They are not lustrous. Not lustrous. They are not conductive. They are not magnetic. They are typically not reactive. There are some differences, but they are typically low to no reaction. Little or low to no reactivity. All right. One thing that we also find as we talk more about this, metals are typically solids at room temperature. And nonmetals are typically gases. That's 100% true the case at room temperature. Every metal, every element could be a solid, liquid, or gas, but at room temperature, the temperature of the room you're sitting in right now, these are typically metals and these are typically gases. There's only two that break that rule, but that's a different video. All right, now for the hard one. It's like, well, wait a moment, we have metals here, we have nonmetals here, where else is there space? Right on the staircase. Right? Because we found that there are some elements that are kind of weird. And the fact that, for example, boron is lustrous, but it's also not conductive. We find ones that are kind of a combination. Silicon is very lustrous, all right, but it has very low reactivity. All right? And so we have these ones that are kind of in between. All right? And so we have this one that's kind of in between here. And these are called the metalloids. Oops. All right, these are the metalloids, and they actually reside right on the staircase. Right on the staircase. The metalloids. I wrote it right on the staircase. All right. One confusion a lot of people want to say is they're like a hybrid. They're like a combination of them. It's not that case. It's not that they're a little bit of each. It's that they're one or the other and different properties. For example, right, I have brown hair like my mother, all right, but I have green eyes like my father. I don't have a blend of those things. I have one trait, one property from my dad, and one property from my mom. So think of metalloids not as a child, but as a little bit of each, all right, or a little bit of one or the other. All right. Some metalloids are not magnetic, but they are reactive. They might be conductive, but not lustrous. All right. There's lots of examples of the ones that go along there. Polonium, right, is not lustrous, but it is reactive. It's a very heavy metal. All right. It's a combination of different properties. Combination of metal and non-metal properties. I just did metal and non-metal. All right, so it's a combination of maybe a little bit of some metallic properties and some properties of non-metal. Kind of just depends. Each metalloid's a little bit different about which combination is it. All right. Okay, so we have things like hydrogen, which is a non-metal. We have things like gold, silver, lead. These are all metals. And then we have things like boron, carbon, aluminum, silicon, the ones touching the staircase, which we will label on our periodic tables. These are the metalloids. Okay, so my video is getting a little long, so this is a good time for us to end up right here. You need to know the difference between metals and metal or nonmetals. You need to be able to identify on the periodic table where are the metals, where are the nonmetals, and where are the metalloids, and what is a metalloid. All right, these are all things. If you can't answer those questions right now, and if I spoke too fast, go back 10 seconds and let me ask them to you again. If you can't answer those questions, you need to go back and watch more of this video. Otherwise, thank you for watching very much, and you guys have a wonderful day. Good luck, and may the science be with you. Bye.